Hello, welcome to video 3 in this series where I show you step-by-step how to make my automated budget spreadsheet. If you want to know all the features this spreadsheet can do, watch video 1, but in case you missed it, here's a quick recap of the 3 most important features. Number 1, only input your income and expenses one time. The spreadsheet projects all your future monthly budgets for you. No need to input the dates and amounts of each of your paychecks. Number 2, enter the settings of your recurring transactions only one time. The Calendar tab auto-populates with the next year worth of future occurrence dates. You don't have to plot them on the calendar yourself. Number 3, tracking your transactions is a breeze. All you have to do is select your description from the dropdown, and the table pulls in your saved settings that you already set up on your Budget tab. If this sounds like it can help you get on top of your finances, then build this spreadsheet with me in this series so you can feel more confident about your budgeting. Or you can purchase the finished template at my Etsy link in the description. Let's get started. So in video number 2 in the series, we got all the formatting set up of the colors and borders so the spreadsheet looks nice. You can go back to do that first if you missed it, or you can pause this video and get your screen set up the way I have mine if you would like. Of course, the colors are customizable. You don't have to use the same colors I use here, but sometimes I do refer to certain sections by their color coding just to make it a little easier. In this video, I am covering the Start Here tab and the income entry portion of the Budget Items tab, including all of the formulas needed to create a real moving timeline that tells you automatically how much income you will have each month. To accomplish this, there are 6 formulas needed that we will cover in this video. Numbers 1, 2, and 6 are very easy. Number 5 is intermediate, and 3 and 4 are a bit more of a challenge, so do be prepared for a challenge in this video. But in my opinion, that's what makes spreadsheets so fun. So as I go through each of the formulas, I would love to know if you want any additional explanation of how anything works. I can make a follow-up video for more clarification. Part of the income section on the Budget Items tab does include those rows for entering dynamic income, which requires a script to run if you want your entries to shift over at the start of every new month. And I'm going to cover that script in the next video. If you don't have any dynamic income, then you don't have to build the script part, and in fact, you could just delete the dynamic income rows altogether. Okay, let's jump in. Navigate to the Start Here tab. The first thing we will do is type in the required categories that should not be edited: withdrawal, deposits, savings, interest/finance. And I like to put a little note on these cells that says, do not edit this cell, used for recording on transaction log, just to remind myself not to edit it, and then also what I'm actually using that for, why I set it up that way. And finally, I'm going to protect those cells so that if I do accidentally edit it, I'll get a warning asking if I'm sure I want to make that edit. For the type of account, I'm going to make this column a drop-down column. To do that, I just right-click and select drop-down. Now, the default in Google Sheets is to use the chips type drop-down, but look what happens if I keep it like that. I can actually select the cell, and if I press the delete key, the drop-down goes away. So I don't want to do that. I always want to keep this cell as being limited to drop-down choices only. So to do that, I'll right-click and select drop-down again, and then I choose Advanced Options, and instead of chip, under Display Style, I'm going to choose Arrow. So now I can't delete the drop-down configuration. The choices for your account types are checking, savings, credit, and debt. The other setting I want selected in these advanced settings is if the data is invalid, reject the input. Google Sheets does default to that already though. A few final touches. I'm going to give myself a note on the balance forward column that says enter the balance of credit and debt accounts as negative numbers. And this is so that on the Transactions tab, it will properly track the balance of the account. And then I'm just going to make the type of account ahead of time in each of the color-coded sections. In the previous video, I explained this is because of how the accounts are displayed on the transaction log. But if you want to see how you could change the account setup on the transactions log for any other configuration, let me know and I'll make another video. Okay, so we're ready to start the Budget Items tab. And I'm actually going to split this tab into 2 different videos. So in this video, I'm only going to go over the income entry section. Everything that has to do with the expense entry is going to be in the next video. So the first thing I'm going to show you is the feature I was absolutely the most excited about in this whole section, and that is this moving timeline that always starts on the current month. It is so incredibly simple, and yet it makes a world of difference. I absolutely did not want to have to be making new tabs for each month, or even entering the date of every new month. I just wanted this to be automatic, and I'll show you how I did that. For this, we use the edate function, and the edate function returns a date that is a specified number of months before or after a start date. So here's the syntax. Edate, start date, number of months before or after. So in our case, we want our start date to just be today, so that it's always moving forward. In this column, we want to be the current month, so we actually don't want to add or subtract any months from this date, so we're just going to leave it as edate today 0. And I can configure a custom date format. I'll click the cell, choose format, number, custom date and time, and then if I select the entries that automatically pop up, I can click delete, so I'll delete those, and then choose the drop down. I will choose month, and then use the arrows to select month as abbreviation with just 3, and then put a space, and then year, and again the arrows to choose full numeric year. And apply, and I like how that looks. Now all we have to do when we copy this formula over to the next columns is change the 0 to 1 to add 1 more month in the future for next month, 2 for 2 months from now, 3 for 3 months in the future, and so on. And I set my dashboard to go up to 9 months in the future. The only reason I didn't do 12 is just for aesthetic reasons, because this is the number of columns that aligns with the same number of columns as my tables down below. So I think it just looks nice this way. But you could easily extend this formula and have more columns going into the future to make a full 12 months if you wanted. And now let's configure the settings for each of the primary, secondary, and tertiary income areas. Again, I want to do some drop downs. The first drop down I want is in E1, how often I get paid. The choices could be monthly, every 2 weeks, or weekly. The other drop down I want is for day of the week, so Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. And finally, I'm going to add some conditional formatting. So the day of the week only needs to be filled out when you select weekly, and the first payday only needs to be filled out when you select every 2 weeks. So if I select weekly, I want G1 to show red until I select a day of the week. And if I select every 2 weeks, I want G2 to show red until I enter a date. So let's set that up. To do that, I right-click the cell, select View More Cell Actions, and select Conditional Formatting. And under Format Cells If, I'm going to change this to Custom Formula. And the formula I will enter is and E1 equals weekly, G1 equals blank. And then I'll just change the color under the formatting style section to be the red color I want, so the user knows they have to fill out that cell. Click Done, and now let's test it. So when I enter weekly in E1, then G1 should automatically turn red. Perfect. Okay, so let's do the same thing for the first pay date section for the choice every 2 weeks. Again, open your conditional formatting menu, change to custom formula, and this time my formula is and E1 equals every 2 weeks, G2 equals blank. So the every 2 week selection is still in E1, but this time G2 has to be blank for this condition to be true. And I'll select the red color. Done. And now let's test this one out. So when I enter every 2 weeks, this cell turns red until I enter a date, and I can toggle between the different selections on E1 to see the different rules that I set up apply. Beautiful. Okay, so let's continue making those same conditional formatting rules for the secondary and tertiary income entry areas. But keep in mind, you'll have to change the cell references and the formulas appropriately for each section. Instead of E1, use E4 and J4. And instead of G1 and G2, use G4 and G5, and L4 and L5. And of course, if you don't have secondary or tertiary income, you don't have to include these sections at all. You could just delete those rows. So the next thing we're going to do is start configuring the pay period section. So I forgot to label these areas in the first video where we did the formatting, so I'll just do that really quick. In row 8, we want to type number of pay periods all the way across. And then in 9, 10, and 11, we're just going to label primary income, secondary income, and tertiary income. So here, the goal is to show in each month how many times I'm receiving a paycheck. And we're going to be using if statements to achieve this. The standard syntax of an if statement is, if a given condition is true, then X is the outcome, else, meaning if the statement is not true, then Y is the outcome. Let's start with the easiest one. So if I get paid monthly, my if statement is if E1 equals monthly, 1. This is saying if E1 is monthly, then cell E9 will return a 1, meaning in the month of November, I am receiving 1 paycheck. If E1 does not say monthly, then cell E9 is returning blank, returning nothing. Now, once we have this formula all done, I'm going to want to paste it in all of these cells. So that means I'm going to want to use an absolute reference for E1. Because if I leave this how it is right now, then when I drag it across, look, E1 is changing to F1, G1, and so on. That feature is really helpful sometimes, but in this case, I actually want E1 to stay the same for every instance of the formula. So what I'll do to make it an absolute reference is put a $sign in front of the E. That means that when I paste the formula across different columns, I don't want the column to change. I always want it to be E. So when I update all these cells with that formula, now each month shows I'm receiving 1 paycheck for my primary income. Now it gets just a bit more complicated. Let's do the weekly option. So we're going to start with our first if statement that we just made for the monthly condition, and we're going to turn it into a nested if statement, meaning there's multiple if statements all inside of each other. Think of Russian nesting dolls. We'll check the first statement, and if that one is not true, we move on to check the next condition, and if that one is not true, we move on to check the next condition, and so on until you find a true statement. So if the first statement is if monthly then 1, then instead of else blank, we actually want to replace the blank with our next if statement. So if monthly 1, else, if weekly, then our weekly result. So now let's think about how we need to configure this weekly result. Well, it depends on which day of the week I get paid, because every month has a different amount of Thursdays versus Fridays, and it's never standard. Some years, one month might have 4 Mondays, but in other years, the same month might have 5, which is why day of the week is a required cell in G1. So here's the formula solution. If E1 equals weekly, then sum the product of the results from the text function, which is converting the day from the date function into its full weekday name. That's what the DDDD represents. And then compare that result to the weekday name in cell G1. The date is determined by the year and month functions applied to the date in E7, and the row and indirect functions generate a series of numbers from 1 to the last day of the month based on the end of month function. I know it looks really daunting, but let's break this formula down into easy to digest bite-sized pieces, starting from the inside and moving to the outside. So EO month, E7, 0. EO month returns the last day of the month, the end of the month. So in this case, the last day of the month in E7. The 0 means I'm not adding or subtracting any months to the month in E7. This is similar to the edate function. Day EO month. The day function extracts just the day portion of the last date of the month. So it's identifying if the month has 30, 31, or for February, 28 or 29 days. The indirect function creates a reference to a range of numbers from 1 to the last day of the month in E7. For example, if E7 is a 30-day month, indirect will create a reference to the range 1 through 30. The row function then returns an array of these numbers 1 through 30. The date function creates a date for each day of the month. It takes the year and month from E7 and combines it with each of the day values from the row function. So when E7 is November 2024, it creates an array of dates like 11/1/2024, 11/2/2024, 11/3/2024, all the way up to 11/31/2024. The text function is used to convert each of the generated dates into the weekday's name, Monday, Tuesday, Wednesday, and so on. And then we have a comparison to G1. So we're taking the result from that text function and we're comparing it to the value in G1. So if G1 is a Monday, check if each date in the array corresponds to Monday. This creates an array of true or false values where true means that the corresponding day is the same as the weekday in G1. Then we multiply those true or false values by 1 because that turns true into a number 1 and false into a number 0. And finally, the sum of the product can add up all of the 1s and 0s. So basically this is counting how many times the specified weekday from G1 occurs in the month of the date in E7. All right, so it looks complex, but it's really not that bad once you break it down and understand what all the steps are doing. So our final step is, what if we have a paycheck that is every 2 weeks? This is one of the more challenging formulas. So let's start by identifying the challenges that we're facing. The first challenge is that depending on which week you get your paycheck, some months might have 2 paychecks, but some might have 3. So we need to know which months have 2 and which have 3. So what we can do is generate a list of dates that our pay dates occur on and count how many of those pay dates fall within the month in row 7. In order to generate that list, we need to know which week the paycheck started on, which is why that first payday is a required piece of information for the every 2 weeks option. And the next challenge is, if we are using this spreadsheet as our budgeting solution for multiple years, I don't want to have to come in and be updating this first paydate cell. I want to set it once and never have to change it again unless my paychecks change. So the formula we write needs to be able to handle a start date from many years ago. And the final challenge is, I don't want to just start at the first payday in the future. I want it to start at the first payday in the current month. Because if it starts at the first payday in the future, then when we're midway through November, my number of pay periods in this current month will decrease as we pass them over time. I don't want that. I want them to always include all of the current month pay dates. So here is the solution. We will generate a column of pay dates using columns A through C. Here are the formulas. In C1, type index filter G2 plus 2 times 7 times a sequence of 3000, 1, 0, 1, year of G2 plus 2 times 7 times sequence 3000, 1, 0, 1 is greater than the year of today plus the year of G2 plus 2 times 7 times sequence 3001, 0, 1 equals the year of today times the month of G2 plus 2 times 7 times a sequence of 3001, 0, 1 is greater than or equal to the month of today, 1. This is going to give us just the first pay date in the current month based on a starting pay date in G2. And here's how it works. Sequence generates a list of numbers, and the 3001 means I want to cover 3000 rows and 1 column. So my list will go down instead of across. Now, because we're also going to filter the results of this sequence, we're actually only going to see one result in the end, not all 3,000 results. And the reason I chose 3,000 is because of that second challenge I mentioned about this task, that we want this to be a long-term solution. So if this number was only 10, for example, then the sequence would start at the date in G2, and it would count every 2 weeks from G2 only 10 times, and then it would stop. So once we get beyond 10 pay dates from the date in G2, our formula will error out. So I was thinking, okay, let's say if I want to use this spreadsheet for my whole life, I'll be really generous and say I live for 100 years. And at every 2 weeks, there's 26 pay dates in a year. That's 52 weeks in a year divided by 2. So 26 times 100 years would be 2,600. And then I'll just be generous and bump that up to 3,000. But remember, we won't actually see all 3,000. In the end, this formula will only show us one date, and it will be the first pay date of the current month. But the formula has to be able to sequence all 3,000 dates initially, otherwise there won't be enough dates in the list it's filtering to work properly, and it will just error out. Okay, the next part is the 0 and the 1 in the sequence function. So the 0 is the starting point, and we want to start from the point of origin, which is the date in G2. For example, if I put a 1 here, then it would start from 2 weeks out from G2. If I put a 2 here, it would start from 4 weeks out from G2. But we want to just start from exactly G2. And the 1 is how many steps we want to take in the sequence each time. And one step is 2 weeks. So, for example, each time I want to show the very next step, I don't want to skip any steps. I want to show every step or every occurrence of 2 weeks. So my step is just one step at a time, just like how we're tackling this challenge. The month and year functions are saying we're looking at the month and year that each pay date happens in. Remember, this is so that we don't skip any pay dates in our current month when we move forward in time. We want to keep all pay dates that happen in the current month. Month and year today are getting today's current month, so these two different month functions are checking, do the pay dates generated fall within today's month and year? If you don't include the year function, if you only include the month function, then the date generated will start in the same month as today, but it will be the year of the date in G2. If the dates don't fall within the current month, that's where the filter function comes in. It filters out any dates that don't fall within this current month. And finally, the index function returns the first value from the filtered array. So what we're left with is the first pay date in the current month after a sequence of every 2 weeks from the starting date in G2. But what about all my other pay dates this year? Let's take a look at the formula we need to do this, and oh, thank goodness, it's simple. I love these challenges, but also they can be a lot of mental effort, so it's nice to have simple ones sometimes. Here's the formula. Array formula of C1 plus a sequence of 44, 1, 0, 2 times 7. So again, we're using the sequence formula. This is familiar to us now. We're generating 44 rows and 1 column, so our list will go down instead of across. The reason I chose 44 here is because if we wanted to project our income for a full year, there's 52 weeks in a year, and if we get a paycheck every 2 weeks, that would be 26 paychecks. So I just chose 44 because it's more than 26, so it will cover all of my paychecks in the next year, but it's not so many that the list becomes too big and unmanageable. Realistically, we could probably change this to 30 and be just fine. Again, we're starting at step 0, which is the date in C1, and we are moving 2 steps at a time, and each step is 7 days. Now, we could change this to be move 1 step at a time, and 1 step is equal to 14 days. Either way would work just fine. And finally, the array formula function allows the formula to generate the list across multiple cells. So we will put in one formula, but our results will actually be a whole list. So look, when it fills, if I try to delete one of these dates down here, I actually can't because it's being generated by the formula up here. And now you'll want to duplicate these same formulas in C1 and C2 over into B1 and B2 and A1 and A2, but change the cell references for the start dates for your secondary and tertiary incomes. So now we're ready for the final part of our nested if statement for our pay periods. If E1 equals every 2 weeks, then count ifs the range C2 through C is greater than or equal to end of the month of E7 minus 1 plus 1. The range again, C2 through C, is less than or equal to end of the month of E7, 0. So the end of the month, E7 minus 1. This is saying, look at the date in E7. Now subtract 1 month from that. So we're looking at last month. And end of the month asks, what was the last day of the month? So what was the last day of last month? Then add 1 to that date. So starting from the last day of last month, add 1 day. So really all we're doing is saying start from the first date of the current month. And the count ifs is saying look within the range of C2 through C, and where the dates are greater than or equal to the first day of the current month, and they are less than or equal to the last day of the current month, then count how many dates fit that criteria. So that is what this formula will do only when E1 says every 2 weeks. And now we can copy that formula across row 9, but remember your absolute column references, your dollar signs. Otherwise, the formula won't work right in the other columns you drag it to. But we do want E7 to be updated to F7, G7, and so on for the month and the year in those columns. So do not put the dollar signs in front of E7. And we will also want to do this same formula for secondary and tertiary income. So copy and paste it in the rows below, except E1 gets updated to E4 and J4, and G2 gets updated to G5 and L5. Again, with the absolute references for those. Okay, and finally, why were we actually doing all of this again? Oh yeah, what we're really trying to accomplish with all of this is to know how much money I'm going to make each month. So one final formula, and don't worry, this is the easiest of them all today. In E15, we're putting equals the absolute reference of E2 times the dynamic reference of E9. We are multiplying our amount of each paycheck by the amount of pay periods in the month. So all of that builds up to just one simple multiplication problem, but it is so worth it. And of course, we can drag that formula across row 15 and then do the same thing for rows 16 and 17, just adjusting E9 to E10 and E11. So you have made it through the second tutorial in my automated budget spreadsheet series. This is the first major one that takes careful attention to detail and some perseverance to get the formulas right. So really, good job to you if you stuck it through. Of course, this took me several months to make, so if you don't want to spend the time, you can purchase the completed template in my Etsy link in the description. Thanks so much for watching. I would love to know if there were any parts that you felt you needed more in-depth explanation. Leave a comment and I can upload a more in-depth video.